just a few examples of the kind of equation solving that we did this week. I've got the inverse operations up here. So remember, we're trying to kind of unwrap the variable by doing the inverse operations of what's happening to it. So we can kind of undo those things because inverse operations undo each other. So if we're looking to get this x by itself, that means I have a 3 attached to it, so times 3, and I have a 5 being subtracted from it. So I'm going to work away from the variable and towards it using the inverse operations. If we're subtracting 5, then I need to add 5 here. What does that do? Well, that makes it 0. Minus 5 plus 5 is like doing nothing. You got to make sure you do it to both sides. That's 0, so it goes away, and the 3x just comes down. 19 plus 5 is 24. Okay, x is closer to being alone, but still has this 3. That means times 3, right? 3x is times 3, so that's multiplication. The inverse of that is division, so we're going to do divide by 3. Divide by 3. How does that help us? 3 divided by 3 is just 1. So this is x equals 24 divided by 3 is 8. X is 8. Okay, inverse operations. Inverse subtracting 5 is plus 5. Inverse of multiplying by 3 is dividing by 3. Another example here. This one's a little different because we have variables on both sides, right? So we got one right here and right here. The only difference is we're going to get rid of them on one side so that they're only on one side. One of the sides we're going to pick to get rid of them so that they're only on one side. So it doesn't matter which side. I'll say I'll get rid of these 14. So since it's a positive 14, I can take away 14 m's from this side. In order to make that a legal move, I need to take away 14 m's from this side. It's just like a balance scale. If you took off 14 pounds on this side, you'd have to take off 14 pounds on the other side if you wanted to stay balanced. So same thing here. Notice that I put these m's under the other m's and not under the 9 because this is not these are like terms. I couldn't take away 14 m's from 9. That doesn't make sense. So I have to line these up with their like terms. So this is 0 here, and then the negative 20 comes down. 14 m's minus, or 26 m's minus 14 m's is 12 m's, and the 9 comes down. Okay, now we look a lot like we did in the last question, right? 12m plus 9 equals negative 20. So similar stuff. Plus 9, I'll subtract 9. That gives me negative 29 is 12m. That's 0, right? And then again, since we're multiplying by 12, I can divide by 12, the inverse. Divide by 12. This one's not going to be as pretty a number at the end, but that is fine. M, and this is negative 29 twelfths. It doesn't look like that can be simplified. If 12 doesn't fit nicely into 29, then you can just leave this as a fraction, 29 twelfths. If you can simplify, as in like there's a number that fits into both of them, then you should, but it doesn't look like there is. There is not a number that fits into both 12 and 29. So there you go. Negative 29 twelfths is the answer. We got rid of the m's on one side so that they're just on a single side, and then it's solved just like the first one. We're using inverse operations. This one's a little different in the way that you have to simplify the sides first by multiplying, but luckily we know how to multiply these two things. So x plus 2 squared, that just means, an exponent of 2 means it's multiplying by itself. So really this is x plus 2 times x plus 2. Right? Okay, we know how to do that by using an area model. So I can make a little area model. It's 2 by 2 since it's 2 terms on each. X and plus 2, x and plus 2, and then they multiply through. So x times x squared, x times 2, 2x, x times 2, 2x, and 2 times 2 is 4. So when I add these all up, that gives me x squared, 2x and 2x is 4x, and 4. So what's that equal on the other side? We got to do another area model. This one is only a 1 by 2 since it's an x and an x plus 1. And x times x is x squared, x times 1 is x. So when we add those up, we get x squared plus x. Okay, so if you have the same terms on both sides, like this x squared and this x squared, you'll notice we can take off the same amount from both sides, just like we've been doing, right? If you take off the same amount from both sides, that's a legal move. But what's going to happen is those x squareds just go away. And now we have 4x plus 4 equals x. Okay, we don't want x's on both sides, so I'm going to get rid of them on one side. I'll leave the numbers over here, so let's go ahead and get rid of these 4x's by taking them away. And that gives us, that's now 0. That's 4, and it looks like a negative 3x over here. 1x minus 4x is negative 3x. We're multiplying by negative 3x, so we're going to divide by negative 3 to get rid of that. And it looks like our final answer is x is negative 4/3. All right.